Welcome everyone to this JSON office hours. Today we will talk about the Oracle Database API for MongoDB. So you've already know, likely, probably, that this is an option on the Autonomous JSON Database, but today we will see that it's also possible to use it on premise. My name is Peter Hammerschmidt. I'm a development director, and with me I have who will give a demo, and also Jeff from the ORDS teams, cause the on-premise support uses ORDS. So that said, quick introduction, or I want to give like a bit of the context here. So our strategy at Oracle Database is that we build like a single converged database. So instead of having multiple like specialized databases that can only handle certain data types or certain workload types, we really want to build a data platform that can handle all the relevant data models, including JSON, and also all the relevant workload types like transactional, operational, reporting, analytics, etc. And this also simplifies technical and practical aspects like securing a database, doing backup, recovery, etc. So we just learned from our customers that they really prefer to have less moving parts when it comes to storing and querying the data. And we call this the converged database. And if we look at the JSON aspect of converged database, so converged database also means like graph and full text search, XML, spatial, etc., but also JSON, obviously. And we've enhanced the SQL language to support accessing values with JSON objects. So you can store them, you can read them, you can extract values, you can index them, you can map relational to JSON and back. So you get like a very powerful ecosystem in the Oracle database to work with JSON data using SQL. But beyond SQL, we also support document store API. So a lot of developers, especially if they write new applications, they don't necessarily want to write SQL statements for simple operations like inserting a document into the database or retrieving it back, finding all the relevant documents. So this is why we added document store APIs and also a dedicated or like an autonomous cloud service, which is like a managed version of the Oracle database in the cloud. So the idea of this autonomous JSON database is that you don't have to like install a database, configure it. It's all done for you. And so you can use these collection APIs, which we're going to look at today, or SQL. But we've also heard from many people that they just want to develop on their laptops. So they say autonomous JSON database or autonomous database is a great idea to deploy code. But for some testing, we want to do it locally. So this is what we're going to look into today. And so autonomous JSON database is not only like a document store like other JSON document stores, but it supports all these other aspects of data, like you want to do some analytics over JSON. We had customers who have reports over JSON, so that is a lot easier to write in SQL. So it's a combination of inserting or updating your documents using document store APIs, but then using the same data, you want to do a report. So we had an insurance company who stored all their insurance policies as JSONs. But then every day they wanted to report how many of these policies have changed, for example. So it's really the full life cycle of documents. So this graph shows it. So an application developer may view the data as documents, and they prefer document APIs, for example, the Mongo API. And they say, I'm pulling JSON documents out of the database. So if we stay with this example of the insurance, then some customer may just log in and see all the contracts they have or all the policies. These would be JSON documents. So the application developer here handles primarily the application objects as JSON documents, but that at the same time for like bulk operations or analytics, machine learning reportings, you really want to use SQL capabilities. So we try to give customers that entire experience and all these APIs in one system instead of using like a dedicated JSON database for storing data, and then another relational database just for queries, and then data has to be moved around. So that creates a lot of friction, a lot of complexity, etc. So the converged database story is that we want people dual access here, both documents as well as SQL. Right, so we supported document store APIs since the beginning. We called one SODA, Simple Oracle Document Access, but we also added an API which is MongoDB compatible. So the idea is that you can come with a MongoDB tool or a MongoDB driver, and you can directly connect to Oracle database. And today, this is available on the Autonomous platform, like Autonomous JSON Database, for example. And here we manage this Mongo API service. But today, it's also possible to download the latest version of ORDS, Oracle REST Data Services. And this now contains the the database API for MongoDB. So this is now a customer-managed ORDS, which allows you to connect MongoDB drivers, tools, programs, and then work with the Oracle database. And what Loic will demo is that it's available on the 21C release, and we're currently testing the 19C code line. And with this, I hand it over to you, Loic, and we're gonna look how this really works in practice.
So thank you very much for all people joining for today. And so as you said, Beda, thank you for the great intro. We will see how we can make it work. So the MongoDB API, or Oracle Database API for MongoDB, for the long name, for on-premises databases. So basically, and Jeff can correct me if I'm wrong, but it starts with Oracle REST Data Services version 22.3. You can click on a link, right? There is a FUTC license, so you can just grab ORDS with the MongoDB API without agreeing for any license. As you mentioned, Beta, it requires effectively 21C database for the beginning, and that's very good news that you are announcing. We are working on the 19C integration as well. Basically, as you can see on the schema here, there are 3 parts play with. So the MongoDB application, which talk using the MongoWire protocol to here Oracle REST Data Services, which translate them in SQL statements, every single order that is received from the application. And so basically today we will see that so far the MongoDB database exposed is of this precise version 4.2.14. So with that in mind, there is some important topic to understand that we do support load balance connections. So it means that by default, we need to have a certain version of the drivers. So here is a list from the documentation. And as well for tools, if you want to use some like MongoDB Compass or the database tools, which contains Mongo export, import, restore, and dump, which are quite useful for data movement, you will need certain version, Mongo Shell as well. So a very quick overview of the so-called connection string, right? For the people not knowing the MongoDB world, so there is like for Oracle databases a way to connect to it. So there are several actually, but we do support some kind of subset, right? So that it can talk appropriately to the MongoDB API. So basically, we'll start with the connection string, which, by the way, is exposed to you once you start ORDS. Or for Autonomous Database, you just need to go to a certain screen in the OCI console, and you can just copy that very quickly. So basically, you will need to pass some credentials, so user and password. That way, then the arrobas, and you would specify the server where the ORDS is running, right? And the port that is exposed, which is by default 27017. And then after the slash, so there is something that is really kind of changing compared to MongoDB, but the fact is that you can actually connect to a database. So here, instead of the user schema, it would be a database. But for the Oracle world, a user, a schema, and the database, the MongoDB database, are exactly the same things. It needs to be created beforehand, and there are some steps explained inside the ORDS documentation, but I will not come back on that. So you need to have some grants, of course, so the app role, for example, and of course, creating sessions and so far and so forth. And at the very end, you've got connection options, right? It looks like an easy connect URL, by the way. So here are the options that you absolutely must use in order to connect to the MongoDB API, right? So the authentication mechanism is plain, the authentication source is external. You need to enable SSL, even if you don't use that, or even if you don't have certificates. More on that here. Retrial rights, we don't need that, and load balance should be true, right? The very last one is actually, if you don't deploy ORDS with certificates, then you need to pass that, especially for MongoDB tools. You would allow to connect to it without certificates. And so it's just give you a very long URL, but that works, right? Next, so I wanted to just explain you as well the way to set up ORDS correctly so that you don't fall into some traps. So you just need, by the way, to read the documentation. It's well written, so all the details are there. I just grabbed some of the most famous errors that we encounter, like, for example, not selecting the proper JVM version. And so we need so far 11 or 17 right now. And those are two LTS versions, so that's really obvious for. Then you can deploy ORDS and the MongoDB API using standalone mode, or you can use your GEE application server. So we do support WebLogic and Tomcat. So next, the installation process. So you can do that either interactively or silently. And for today demos, I just selected the silent mode, which is quite useful, for example, if you want to create Docker containers, right? Because I did that. And once you have deployed ORDS with the MongoDB API, you can actually use much more than just the MongoDB API, because it comes with autonomous cloud services, all the database actions. So you can benefit from that from a long time, since some months. And so you can precise that, Jeff, but you have all the tools available as well on premises. And then you can have as well the RESTful web services enabled, so you can just manage APIs which are backed by SQL or PL/SQL endpoints, for instance. You can enable quick access to tables through REST APIs. So you just did one command. It's called auto-enabled tables. And then you can as well leverage the SODA API, so the simple Oracle document access through REST. As well, we give you an example just after that. You can load data using curl commands. So quite convenient tool, in fact. And so here are very basic commands that I did use. So after, of course, deploying a 21C database, so here I chose the XE Slim Docker image, which is really, really small, so quite kind of between 2.5 and 4+ gigabytes. So Gerald Wenzel did a very great work here, building this very small container. Then I just needed to install the JVM, download it with one click the ORDS latest zip file, and zip that, run the silent installation. And I did use the following commands. So that's really the macro commands, the most important ones that I did run during the building of my Docker image, or if you want to do that natively, right, on your own laptop without Docker. So quickly, you need to specify a configuration folder, and that one you need to keep it for every single command you want to use. Then you run here the install, you use the sys for granting roles and all these privileges that you need for enabling ORDS and RESTful Web Service and database action. So you can enable that with these flags, right? So here's proxy user is recommended for setting the ORDS public user, which is used as a proxy actually to run all the SQL commands. And then I just pass, okay, so very basic information like the local host, the database port, the PDB name here, or service name of the PDB. And then I needed to just configure afterwards, so after the installation, to here enable the MongoDB API. If you want to enable as well the in standalone mode, the database actions will need this second configuration command. The later ones are really best practices about here. So the size of the connection pool. So this one is just restrained because I have an express edition version of the database, but you probably want more than 20 connections in your pool. So for development or testing, that's really convenient. And then, so what I can show you is that, so I did use that. So that's a script used in the Docker file, right? So that's one I grabbed from Tim Hall from Oracle Base. So very, very helpful, thanks to him. And I just needed to move some part away, like Apex deployment, but yeah, you could add Apex as well if you wished. So really basic scripts to get started, and then
so sorry, that, like this script you had to modify it, or the script is part of the Docker?
So this one is a script I did grab from a very famous Timothy Hall scripts from Oracle Base. So you just need to clone a GitHub repository, maintain, and I just needed to remove and just enable the MongoDB API here, right? And so as a very next step, what I did is just creating this kind of very small lab, right? So that's running actually currently on my laptop. And I did use something that probably every Java developers know about, which is the Testcontainers tool, which, by the way, is really easy to deploy containers and to test their code. Right. So what I did right now is just I leverage some of the features from Testcontainers, which can actually deploy several containers together, link them over a network, and don't stop the container necessarily if you don't need to, right? So right now there is, I did run this, so a Maven command to just run the test. So this one is available on GitHub repo. And you just need to clone it and to run the Maven test command. So it will basically deploy 2 containers with dependencies managed. So it will start the XC21C Slim image first, and then it will deploy the ORDS plus MongoDB API image, and it will link both of them over a network, right? Exposing the port 8080 for me and 27017 for MongoDB API. So we will use that, and basically that's kind of deployment that you could have as well on premises, right? If you just remove Docker, you could have exactly the same thing. It allows you then to connect any MongoDB-based applications and client to the ORDS MongoDB API, or you could use as well database actions that we will do just afterwards. And for the one that want to just leverage ISO standard SQL 2016 over JSON, they can do that with reporting BI or analytic tools directly using plain SQL. So just a summary of what we'll see just after. And so it's demo time. If I run here the Maven command, so you will see several things occurring, right? So that's a very basic single JUnit test, which deploys both containers, right? So in fact, they are already deployed, and I'm using the very famous reusing feature of Testcontainers, so very, very useful. And you can see that with that, in fact, for the test, according to the test itself, the containers are really starting very fast, like 1 second and 3 milliseconds for the database, and you've got less than a second for the ORDS container. And then I'm just initiating a MongoDB pool, connection pool in Java, and then gathering the actual version that is installed with the MongoDB API. So all of that is available through Java. So you can just grab the clone against the test. And this is really a basic test, so that can very easily start a configuration for you, right? So I'm using that, and I feel that every Java developers are already using test containers. So next, what I can show you is that if I do a Docker PS, what you can see here is that I have actually these two containers here. And the second one, which is the database, will as well have the network, right? It will host and expose the ports itself. So you can see that my local port for the database is this port. And for accessing database action, I will use that port. And for the database API, mapped to that one, or precisely with IP.
This is just port forwarding into your
absolutely
process, right?
Yeah, a
exactly,
classic Docker port. Yeah. So if you see me using that port, it means that I will connect to the MongoDB API.
Yeah.
So what we could do next is, well, we can start using the different tools we have. For example, I've got MongoDB Compass, right? And what you can see here is that there is this famous connection string. So if I edit it, you see that I have a test user. This is exactly the same test user that I've configured with test containers inside the Oracle database, right? Inside the PDB. So I will connect to it, to the exact same user, and then I will use, as I mentioned, all the parameters that are mandatory. So I did add that one, because I have no certificates, and here that's just a code for the dollar character. And so let's connect. So this is completely local to my laptop, and so that's so there is no cloud service. Everything is running on my box, right? So now I'm connected to the test database, and what I can do is actually I can create, for example, a collection. So I will load here movies data, and so I create the movies collection. So here it is. I can import data. So let's go for selecting a JSON file containing some movies JSON. So here is 5 megabytes. And then I can just import it very quickly. And you will see that, well, it runs and it works, right? So here loaded almost 4,000 documents, and here they are, right? They are right inside the Oracle database and available through the MongoDB API, of course. So what we can do next is, for example, if we like writing queries that way, so we can filter like the movies that can be found at a tier, right? So filtering very conveniently like that. I could use the integrated Mongo shell as well, right? So if I do that, I can just grab some commands, and I can, for example, could count the number of documents right inside the collection, or I can just retrieve all of them, or I can even use some kind of advanced queries. So I can filter still with the same year, and then I can sort by the movie ID field in a descending order, and get the last two documents, right? Like that. So it works, but if you are not sure, what we can do is we can just verify that using database actions. So
one second.
Yeah,
like,
sure. Yes,
so
please.
the one comment would be that these filter expressions, this JSON way to express a query, that is not limited to just one equality check, right? Here we say year is 1976, but you can also do ranges where year is greater or equal, and you can do and or combinations. So just to make sure everyone maybe we have some people who used MongoDB and they're asking themselves, like, how far does this go? So yeah, you can do and or greater regex, I think. So it's a pretty powerful filter expression there.
Yeah, exactly. And you know, we have exactly the same thing for Soda API, right?
Yeah. So you could even like say year greater this and price smaller that. So you don't have to do that, but just to understand exactly. Yeah.
Yeah, you can project as well.
So these expressions can be pretty long. So at some point, SQL looks more beautiful than
sometimes. Yeah, it's more convenient, or you understand more because you know SQL.
Exactly. Right? Yeah. Okay.
So let's go for database actions now. So just clicking on the link, and here you see that I'm connecting to the forwarded port to 8080. And then I'm just asking for the ORDS, here's the schema for test user, and I can just sign in like I do usually for on the OCI console with Autonomous Database Cloud Service. So now I'm connected. We should see a table which is called movies, right? That's here. If you want to have approximately the same look and feel as for the MongoDB Compass, you can go to the JSON database action. Right, and so you can see that clicking on here, I can see all the content of the movies collection as well, right? Mm-hmm. And I can filter here in the same way as I did. I can just go quickly because what I wanted to show you as well is that, as you mentioned at the very beginning, we can do SQL on this collection, right? Look at the columns defining my tables, which is storing actually my data. And you can see that the data field here is actually a JSON native data type. So that's why right now we need a 21C database. It's because behind the scene, we will use the binary encoding of JSON documents. But then what we can do is go a little step further, and we can start querying this data column, right? So I'm just retrieving the 5 first documents in any order, so not sorting here. But then I will want to prettify the documents, right? So I can even remove that, I think. And if I run that, well, I will just see my data, right, being contained inside the collection. And so, as you can see, I can have quick overview, so very, very nice to very quickly look at the field. And here you can see that it's formatted with a pretty format, so every field are indented and so on. But then what I can do is actually I can leverage here what we call the SQL notation, and then I can filter out the same way using plain SQL code, right? So here filtering with the year, exactly the same, and sorting by year as well. So putting years at the very end because that's something that is really possible with SQL. So we will see more advanced SQL obviously in a moment. Right. So here we have tabular data of JSON data. So that's really, really nice. But sometimes we have some complex form of data. And so as you mentioned, we have a bunch of SQL function. And one of them is really, really nice. It's called JSON table. And it has inherited from a very convenient a new notation with 19C, which make it really, really smoother to write. And I will just show you that in a moment. So you can see here, for these movies, we have casting, right? So we have actually the actors and actresses participating to the movie right at the bottom. So what I will do is I will not write, but just copy and paste the query here very, very quickly. But I will define that for you, right? So here, and I will start again from the very beginning, which is basically that one. So what I can do is actually query from this movies collection, and then I can kind of drill down inside the JSON hierarchy itself, right? So I'm beginning as a data level, so it's a column, right? And what I can do is I can just grab the year and I can cast it as a number, right? It will be a number so that I can do counts on it, sum it, do every single operation that are 4 numbers. And then you have seen that the cast field is an array. And so the way to unnest it is using the nested operators here. And so I unnest the array, and I will just grab the actor field, which is, by the way, the path being, the JSON path being itself. And so if I run the query, you will see that every single actors from all the movies will be just a full list with the year. So the year of the film, so I didn't put the name, but I could have, or the title here, like that. And if I run it, I will just have the title, the year, and all the actors and 1 actor per row. So that's the easy way to actually unnest data from arrays. And I could do that indefinitely with different hierarchies level. So if I continue to do that, so just explaining here the query so far. So I did add some filter values because sometimes there are, you can see here, null actors. We have put null values, or sometimes there is even the no value. So I'll just filter that out after nesting the data. And then I can just do very nice analytics like group bys, order bys, fetching only the 3 last rows after the ordering. And I can count the number of actors per year. And here I will just grab the 3 most not popular, but the actor and actresses that have participated to the the more important number of movies, right? The more popular, but well. So let's see what it means here. And you can see that I've even retrieved the minimum year and maximum year of the movies, right? So here are the 3 most famous actors. So with that, let's go to another thing that is very, very nice, is that you can have REST APIs with ORDS, right? And so if I still connect to ORDS 8080 port, I can actually gather every single collection exposed through the SODA API, right? And I can see that I have got my movies collection, which is by the movies table, and it has the JSON native data type for the data column. And then I can as well use very interesting filtering way. So you can expose your REST API that way. And this way I can just filter with, movies from this year.
So you basically get SQL access, you get Mongo access, and REST access as well.
Absolutely, yeah.
Without having to set it up separately, it's just out of the box. It's there. Yeah.
So that's the first demo I wanted to share with you.
I really like this demo, because people may say, "Oh, let's build an application where all I have to do is store and retrieve some movies that I want to sell." But then this use case of finding what is really inside my data, which are my most famous actors, etc. I think that arises in many use cases. And it shows that an application is not entirely operational or transactional. You will always have these. Maybe analytical is a bit far-fetched here, but where the query results depends on scanning or looking at all your documents and extracting something out of it. And that's an example where we see people then saying, "Oh, can't do that with my JSON-only database, have to load it somewhere else, etc." So I think this demo really shows both these access patterns. Yeah.
And it's only the start, because I didn't show you how we can actually do joins between JSON and relational data if you need it, for instance.
Yeah. So you mentioned this JSON data type a couple times. So we're storing the JSON not as texts or in MongoDB's BSON format. So we have our own binary format, which is optimized for database use cases. So what does it mean? It basically means we can very quickly extract the values that you're interested in. So we saw these queries where you looked for movies in a certain date. So then we don't have to scan the entire JSON to find it. So this binary format basically allows us to jump at values of interest. And that makes it very efficient and fast for queries. And this binary JSON type also is optimized for updates. So we haven't seen updates yet, but if you do updates, we don't have to like replace the entire document with the updated versions, but we can do piecewise updates. So that's kind of a benefit of this data type that you mentioned. Yeah.
Second demo, some more interesting maybe for people actually wanting to migrate. So what I can show you is that, so I've got as well a MongoDB database running. So that's this one. And this MongoDB database has some collection here, products and users, and they participate to an application, a MERN application. So that's a very famous stack outside where you've got a lot of websites designed and developed with that. So we'll provide you as well the GitHub repo. It's completely public. And so what I did is just I retrieved the code of the application, so named ProShop MERN. And what I did is just configure it, right, to run with my local MongoDB database. And so if I start it right now, you will see that I can connect to it. So it's starting a backend and then a front end. So it's all JavaScript code. But most importantly, you will see that with very minimum, and that's just configuration. So I would just talk about that while it's starting. The changes that I just needed to do, and they are very, very short, right? So I just needed, for example, to update the Mongoose version. So Mongoose in an ODM, so to do the mapping between JSON and JavaScript objects. Remember the version of the driver to support load balancing properties. So I needed to update that. And then because of that update, I needed to remove properties that have been deprecated right now. So it's like they are true by default right now. So I just needed to comment that to avoid an error. And then installing the application, configuring it that way, connecting to to my local MongoDB database, I can show you what it's like, right?
So while we wait, like we saw these query expressions in Compass, for example, where you again looked at these movies and exactly these stuff. So the database actually never sees this filter expression. So this actually gets rewritten to an equivalent SQL statement. So the database never sees an expression like this. So the what we do in this database API is that we look at the statement and we convert it into an equivalent SQL statement. So we understand that not everyone wants to write SQL, so we write SQL for them. It is not that we build like a NoSQL engine in the database or like some MongoDB database, MongoDB code in our database. Not at all. We just take these expressions and we rewrite them to SQL, which also means that the optimizer is aware of it. Like if you have a DBA who knows how to analyze SQL traces or look at explain plans, etc., then this becomes extremely easy because that DBA can like reuse all that experience that she has in optimizing queries, for example.
Just going quickly, right? So here is the websites so you can order anything. And what I can do is I can log out. I will log in as the admin, and I will, for example, change the price, right? So here it's 39, and I will just update that. So it should be products menu, and I can just.
And this is not an app you built, right? This is like an app you found in the internet. So Oracle has no affiliation with whoever built that. This is just some demo code that was written for MongoDB.
Yeah, definitely something that you can grab yourself. And again, the link, we can provide that definitely.
So we made no changes to that code to make it run on our platform.
No.
As is, cloned from GitHub.
And you just updated the Mongoose version, and that's all. So the very next thing that we want to do right now is migrate the application. So what we'll do is we'll first need to migrate the data, because as you can see, there is still just one collection available here. And so for migrating, I told you about the Mongo export and Mongo import tools, or Mongo restore and Mongo dump. So I will do that right now. So I've downloaded the database tools for Windows here. And then I can run the MongoDump and connecting to the local MongoDB database that way. And so it will be stored inside some dump subdirectory. So here, dump being the whole database here. And what I like about MongoDump and restore is that you've got some files under, dump MERN demo folder. Here, you've got those data stored as BSON data, and you've got the JSON metadata, which are files that contain the ways to recreate MongoDB indexes. Right, so they are very, very important. And Mongo export and import do not manage indexes. Right, so you have to keep that in mind when you want to migrate a MongoDB database, because you need these indexes for performance, obviously. And so the very next command will be to restore. Right, so that one is it needs to connect properly, just like that, to the using the MongoDB URL, so exactly the same one. And then I will go with the MERN demo as the source. So in the dump folder, retry write false. So that's mandatory for now. And TLS insecure has the same option for bypassing the certificates verification. So doing so will restore the data, and you will see that either using MongoDB Compass, the collection that we just retrieved and loaded. If you look at database actions, you see that you've got your data as well. So now the very last thing that you would need to do is to, let's stop it right now. And then let's switch the MongoDB URL and restart the application. So we start again, but this time it will connect right through the MongoDB API and the Oracle Database Express Edition 21. So here we are connecting for the backend, and yeah, it started again. But this time it will connect right using all the stuff that are deployed on my laptop right now. So what I can do during this time is you mentioned something like updating and piecewise update beta. So if we look at the data from the products, remember I just modified the price of the mouse, and so it's here, right? So that's the price for the Logitech. And so what I can do is I can use this JSON transform function to do piecewise update of the price, right? So I can change it back to 39, right? And I can manage the errors here. For example, if the field is missing, I will throw an error, because for me, that's a field that is absolutely mandatory for my products, of course. I will just check that it is the same ID. So just looking at the ID here. So the ID column, by the way, is actually the same as the field of the MongoDB object ID stored inside the JSON document. So let's run the piecewise update. One row updated, and let's check that again. And the mouse should be cheaper.
39, yeah.
Here it is. Yeah, the mouse is now cheaper, and so I can go to buy it, right?
Good.
So I will, for example, log out, and I will log in as John. John is
the user,
customer, and so I can just look at that one, for example, and I can just say, hey, I like it. Oh, that's here. Good. And submit it, right? Or is it okay? Yeah.
We have to put in a comment where it's.
So we can retrieve the views later on, but what I want to do is actually to buy as my mouse, because now that it's cheaper. Okay. Then it can place the order, and it is developed to connect to PayPal, so I will not allow to do that. But so we will look at the order. So I will just buy another item. What do you want, Peter?
I take the PlayStation. I never had one.
Yeah, good choice. I will just send it to you. So US, so I don't know. Well, let's go for that and Redwood City, right? And at home, yeah. So just continuing the order. So I'm just doing that so that we have two orders because I want to show you something just afterwards. So
Good.
we have the orders. And so if we want to go, for example, here and just look at the data here, the orders, we can do like the same thing here. So we just copy and paste it. And the orders, so same data. And I should have two orders, one for you and one for me, or for France and one for US.
There's two orders.
So two orders. We should see that here's the shipping addresses, and it's
tour of
yes, France. Yeah, so that's me. So I wanted just to finish with this reusing again. You know, I really like this JSON table function, or its simple way to write. And so I wanted to do some quick reporting for my orders, and to get in which country I get the most sales, right? So here, okay, only one for France, and I've got the item here, but here I'm using an analytic function, right? So counting for any product, any order grouping by country. And so this allows me to go to another feature which are very, very lovely in ORDS are the charts, right? You can define your own charts. So I can do that here and edit. And you can just copy and paste some queries, right? So that's exactly the same one. And the result after publishing the chart is that I can open that and monitor it in real time, like this. So here are my orders, one for France, but half of it for France and half of it for US. And then I can just watch the screen, refreshing every 5 seconds and see how it goes. So you benefit from a lot of tools. That's the message I wanted to
And it's the same tools that you also
you.
get on Autonomous, right? So if you go to the cloud, all these, the charts, the SQL Developer Web, the JSON page, they all look and behave exactly the same, right? So whether you use like your on-premise database here or the cloud version, it's the same environment if you use Oracle's tools there,
Yeah, that's it.
Yeah.
So I finished migrating my application. So now I can hand over to you.
So there was one question, I think it's actually the most important one about the compatibility of this API. So the question is it 100% compatible? And the short answer is no. But let's dig a little bit into it. So as I explained, we take these Mongo operations and we rewrite them into equivalent SQL statements. And parts of these operations are also regarding login, logon. So you've seen like how he logged into this applications. So we do intentionally not follows MongoDB's security roles grants model. But instead we use oracles. We just feel it's easier for an Oracle user to have like one consistent user grants role model across all their applications. So if you come in with the MongoDB API, it's the same grants and roles schemas that you are used to. So if you have an application that heavily relies on like some very Mongo specific roles or grants, then that is probably not working out of the box, and one would have to modify that. So that's very intentional. But obviously as well, since we are in the business of taking Mongo queries and rewriting them to SQL, not everything works. And if you look at the aggregation pipeline, that is an area where we are still actively developing, but what's available or published as of today is limited. So the aggregation pipeline, I would say, is like the level of compatibility is quite low as of today. But that's actually exactly where the SQL area has its sweet spot, right? If you want to do like aggregates, reporting, etc., a lot of customers then actually prefer SQL over the MongoDB aggregation pipeline. So that possibility always exists. But that said, we also work actively on increasing the compatibility. The other part to really understand here is that the Mongo API is really just a channel into the Oracle database. So everything you do is fully transactional with the same transaction semantics as all of Oracle. You can have like triggers, you can have stored procedures, you can join your data. You can not only join JSON with JSON, but also JSON with relational data or spatial data whatsoever. So it's really one channel into the converged database. You can also take like query results from SQL, convert them back into JSON, and even map those to a report Mongo collection. So if you wanted to read from a Mongo tool data that's been generated by SQL using views, etc., that's also possible. We haven't shown it in this demo, but it's something you can assemble by combining different building blocks. Yeah.
I think there is another question.
Do we have benchmarks that compare AJD versus Atlas? Yes, we have. While you continue, I'll grab out a blog that compared AJD versus Atlas. It's also, so Atlas is MongoDB's cloud version, and we have Autonomous JSON Database, which is our cloud or autonomous cloud database. So it's the Oracle database for JSON workloads. And the blog I will put in the chat will basically say we're 2 times faster, I think, on average. It's cheaper, and you get also SQL access. So it's kind of more features, faster for a lower price. And now let me dig out that blog post. So yeah, I think here you had put together some links, like, right, on where to find more information. Yeah.
Some related to Oracle REST data services, so how to download that very quickly and conveniently, the installation guide, of course, but I should have put your blog, Jeff, because, well, you do an amazing job, right? So advertising all the possibilities of this very, very, very good tool. And then you've got the documentation link to the MongoDB API, which basically are the same for the cloud and for on-premises. Installation steps, so a very good blog post written by Roger Ford, which works as well for JSON capabilities for the Oracle database. And you have 2 JSON LiveLabs. So I believe, they both were with the MongoDB API. There is another one, but I didn't mention that, so probably we can add it as well.
Yeah, we'll add it put a link under the recording. Yeah. The Autonomous JSON Database was launched, I think, 1.5 years ago. So it's we have our autonomous databases, so you can get a managed Oracle database as a cloud service. And there is one like general purpose for transaction processing called Autonomous Transaction Processing. There's one for warehousing, and there's one for JSON. And so we created a service about 1.5 years ago for JSON workloads to directly compete with databases that can only do JSON, like MongoDB Atlas would be one. And we took a benchmark here that MongoDB had published at that time. And this is an industry benchmark called YCSB. And we run it on the same hardware, and we found out that Oracle is actually faster, mostly because of parallel processing. So we just have like many years of experiencing with concurrency, like with concurrent workloads. If you have interleaving reads and writes, these kind of queries, we're actually pretty good at executing them in a concurrent fashion. So this is why these numbers are better than the competitor here. But the interesting thing is, as the person asked about Atlas, is that also from a pricing point of view, you get this better performance actually for a lower price point, and I believe even with more storage. I think we give people like 1 gigabyte. Atlas gives them 320. So there's like a lot of benefits aspects why Autonomous JSON Database is better than Atlas here, also in terms of shapes and auto-scaling, etc. Yeah, so there's a lot of information in the blog. We don't have to go over all of it.
There was a last question, right? Why AJD is actually cheaper than ATP?
Yeah, it is. Yeah, it's actually the same database as ATP, but there is this 20 gigabyte limit. So you can store even relational data, and you can use all of SQL. You can join JSON with relational, etc. But the moment your usage becomes primarily relational, or a lot of relational, and a lot means more than 20 gigabyte, then we will ask you to upgrade to a full ATP. So then your costs will go up because ATP comes with a higher price point. I think it's 4 times as expensive. Yeah. And but both are available also in the always free tier. So you can I don't know if you have a cloud account, but it takes like 5 minutes to sign up with Oracle Cloud. And then you get this always free tier account, and there you can create up to 2 databases, version 19C, 21C. So you could get like an always free 21C HAD or 19C ATP, etc. Thanks, everyone.
Okay. Yeah, thank you.
Okay.
Bye.
Bye.